Welcome to August Leetcode Challenge. Today's problem is Iterator for combination. Design an Iterator class which has a constructor that takes a string of sorted distinct lowercase English letters and a number, combination length, as arguments. Basically, the length is going to be the length of the string combination. We also want two functions, next, which returns the next combination in lexicographical order, as well as a function hasNext, which returns true if there exists a next combination. So that's going to end when we run out of combinations. All right, so the main meat of this problem is to figure out how we can generate the combinations. After that, the next and hasNext is fairly simple. All we need is some sort of counter in our object to indicate where we are. And once we've gone through the entire list, we could just say there's no more. So let's think about how we could first generate all our combinations. The easiest way that we can do that is to use libraries. There's a library called itertools, as well as a method called combinations. And this is perfect for our problem here. What we would do is input our characters as well as the combination length. And that's going to return to us a list of tuples of all the possible combinations for our string. But that's going to be a tuple, so we'll have to also regenerate those into strings. And we can just do that by using the string join method for t. So for t, all these tuples in our self.output. So now it's going to be a list of strings instead. Now to get these two functions to work, we need some sort of counter. So we'll start with pointing at -1 because we haven't started yet. And for next, we can use this method function here to say if there is a next combination, well then we will increase our counter by 1 and we'll just return the current index's string in the output. So that would be self.current, like this. As for hasNext, well, that's just going to be a boolean, so we'll just return, check to see if self.cur plus 1 is less than the length of our output. As long as this is true, then there should be a next combination. So let's go ahead and test that. hasNext not defined. All right, forgot to put self here. And it looks like it's working. Let's go ahead and submit that. And there we go. That's accepted. But this in some ways is cheating because you're using a library. Now, what if we weren't allowed to use libraries and we'd have to generate the combinations ourselves? That's a little bit trickier. You could do that recursively, but I'm going to do it using a queue because I just want to avoid having to think about all this recursive calls and stuff. So to do that, we still need to generate an output. We'll start with just a blank list, and we'll still have our current pointer here. Now the key is, well, we need to set a queue. So queue was just going to be we'll set a queue, and to this queue we'll append a tuple of our temporary string that we're generating, as well as where we are inside of our main character's string. So this would be just a tuple, and I'm going to say that a blank string as of now, and we're starting at 0. Now, while we have objects in our queue, we're first going to pop off from the left, and we'll say this is a temp string, and this is whatever our current pointer. Okay, so the first thing to say is, well, if this temporary string is the length of a combination length, we should just append it to our output, and that's it. We're done with this queue, this single queue. So if the length of temp is equal to combination length, well then let's add that to our output. And that's it. So we've got to make sure to just continue here because we don't want to end up adding more. Now finally, for our current that we've popped off here, we're going to add, we're going to go through a for loop and add whatever's next to the right side of this position. So for I in range of, I believe we'll say current, to the length of the outlet, let's initialize that as length of characters. What we're going to do, we're going to add to our queue a tuple of temp plus the characters I, as well as the I that we're on. That should kind of do a breadth first search of, well, we got to add one here. To generate all our combinations. And what's nice about this is it's going to be in order at the very end on its own. So let me see if I got this right here. I'm not totally sure. But let's see if I print it, would it look like what's supposed to? So it looks like it's working. AB, AC, BC. And that's all three possible combinations for ABC, and it's in order, right? So let's see if we submit that, what's going to happen. And there, accepted. So that's great. Now, one thing to note here, they give us a hint to use bit masking to generate all combinations. And I'm just not going to do that. I am not really comfortable with how this bit masking thing works. I can give you a basic understanding. Basically, what they're kind of expecting you to do is say that we have ABC. Each one of these positions is going to represent one of those letters, A, B, or C. So if we just got all possible combinations with a length of 2, so say it's going to be like, end up being like something like this, and then 101, as well as 110. These are all three possible combinations. And we can use this bit masking to generate our combinations. Like this would be BC, AC, AB, and have to be in order as well. And that would save a ton of memory in terms of, like, you know, here I'm kind of wasting a lot of memory from generating all these temporary strings. This would allow us to save a ton of memory, but it was just too much to me to really understand, and I don't want to explain something that I'm not comfortable with. So if you want to look into it, then I recommend it. But really, for just general concepts and like interviewing, I don't see that being a huge advantage. So, all right. So thanks for watching my channel, and just want to say, do not trust me. I know nothing.